So today we are going to do the lesson slightly differently. I know some of you have attended my previous lessons where we share content about different topics, for example, organic chemistry, electrolysis, and some other chapters like mole concept, acid and base, etc. Now, today's session will be run in a way that instead of us going into one specific topic, I'm going to use questions, okay, for you to be able to understand the topic and recap some of the key important points of each chapter. So I want you to be able to follow with me. Not to worry if let's say that you haven't do this paper yet, okay, it is actually not meant for you to do the paper first. It's meant for you to follow me together and let's try to attempt this together. All right, and today's paper will be on Cedar Girls Secondary School Prelim last year. Right, so today is a paper 1 for this school, and then tomorrow we will attempt the paper 2 for the other school. All right, so if let's say you have any questions at any point of time, please feel free, type inside the chat, okay, if you have any questions for whichever question. All right, so I'm going to explain the certain concepts, and as well when I go through the questions, if let's say you want me to highlight or you want me to revise with you a certain concept, you can also do that inside you can also let me know inside the chat lah, huh? Okay, so most of you are my familiar students, so not to worry, like you just type whichever questions that you are not familiar with, okay? But for the new student also, not to stress you too much. If let's say that you are not following with the pace, please let me know, okay? Then we will go through together, okay? All right, now let's look at question number 1. Now, in this question, okay, we are given a diagram, right? And this diagram is on paper chromatography. And you can see over here that you can see that X is the dye, and this dye, okay, I'm going to put it over here and it's going to travel up. And when it travels up, it splits into 2 different dyes. And this brings me to my first concept that I want to revise with you, which is about chromatogram. Okay, now in the chapter of separation techniques, okay, now what is paper chromatography used for? Can anybody tell me inside the chat? Okay, what is paper chromatography used for? Anybody know? Anybody know what is paper chromatography for? Okay, good. I have an answer. Okay, checking of impurities. Okay, good. Any other idea? Anybody have different answer? Okay, yes, checking of impurities is one. Okay, checking whether it is a simple substances. Okay, or is it a pure substances? Now, okay, good. I have another answer to separate the soluble substances. Okay, true. That is also true. Okay, so chromatography is to help me to separate. Okay, separate into the simplest dye. So for example, if let's say I have a color over here, maybe it is made of green. Okay, this is green. When I put it through a chromatography process, maybe it will give me blue and yellow. So you can see how the 2 colors, okay, the 2 colors added up actually forms what is the starting that you have, right? So if let's say I have a material that is made of 2 different dyes, it will show up at 2 different points, okay, in the chromatography. So this is how paper chromatogram works. And it's important for you to know, because if let's say I have one single dot, okay, one single dot after the chromatogram, which means that if let's say I start over here, okay, I start over here with maybe let's say W, okay, it just travel up and then it form a second spot, Z. Now, can you see over here, if let's say that the solvent front continue to travel all the way up already, there's no other dye, there's only one single dot. If there's only one single dot, you can safely conclude that this is a pure substance. Okay? Whilst if let's say that there are many different dyes, you can say that it's impure. Okay, impure because it splits into 2 different dyes, right? Which means it is a mixture of different dyes, different compounds. Yeah. Okay, now what I'm going to do now is I'm going to look at the next diagram, and then after that, let you compare something, okay? Now, let's look at this. Diagram number 2, it asks me to, shows the cooling curve of substance Y. Okay, so substance Y is over here. Now, substance Y has a curve that is as such. So the temperature goes down. There's a flat plateau in the temperature. Okay, there's a fixed temperature whereby over time, the temperature doesn't change. And then over here, the temperature start to decrease. Now, what I'm concerned about this question is not so much about these two curvature. Okay, what is most important is about this flat part over here. Okay, this consistent temperature with time. Now, this is where we can identify that it is a change of state situation. Now, remember, change of state situation is often or most of the time accompanied by constant temperature. Why? Because all the energy that is being absorbed by the substance or lost by the substance is getting converted, okay, into the change of the state, which means from the solid to the liquid, or from the liquid to the solid, from the gas to a liquid, from liquid to gas. So in this case, it's a cooling. Okay, it never tell you whether it is a melting process. Never tell you whether it's a freezing process or is it a condensation process. But what is most important that is you need to know that the temperature is dropping, and here, okay, is flat line, okay, flat line constant temperature. So there is a change of state. Okay, so when this change of state is across a fixed temperature, we can conclude that it is a pure substance. Okay, we can conclude that it's a pure substance because when it's a pure substance, it melts or boils or it cools or freezes on a certain fixed temperature. Okay, on a certain fixed temperature. Whereas, okay, if let's say we are dealing with impure substances, okay, what is going to happen for impure substance? Okay, they are going to change of state. By the way, the triangle represents change of state over a range of temperatures. It is not going to melt or cool or freeze at a fixed temperature. Okay, Kenna? Any question? I hope it's okay. Okay, now let's move on to the next one. Okay, X and Y. So which statement is correct? So you can see X is going to be a mixture and Y is going to be a pure substance. So option A is correct. Okay, the rest I think I don't need to go through, right? All of these are wrong. Okay, so most important, you need to know that Y is a pure substance because it cools at a fixed temperature. It changes a state at fixed temperature, whilst X, okay, because it's split into two different dyes, okay, you know that it is impure substance, okay, a mixture. Okay, now this is for question one. Let's go on. Now, next one. This one is about the process of diffusion. Okay, this question is a process of diffusion. Now, we are told that there is liquid bromine that is placed at the bottom of a glass jar. Now, brown fumes, okay, slowly spread through the covered glass jar, right? So the keyword over here is it slowly spread through. Okay, and what is this brown fumes? Okay, this one actually is bromine. Hey, bromine. Now, because of the fact that there is bromine that is over here, okay, you put liquid bromine, what happened? It vaporize to become Br2 gas, right, at the bottom of the glass jar. So imagine if, let's say, this is my table, I have a glass jar over here, okay, I have a glass jar that's inverted. Okay, I put a drop of brown color bromine over here. So what is going to happen? What will you see? You will see that there will be fumes of bromine that is going to travel, okay, travel up. Now, when you see this, you must always remember there is this thing known as diffusion, which means from a region of high concentration, okay, concentration, always go from high to low. Okay, always go from high to low. So that means, okay, this is a process of diffusion. Okay. Now, that means here is a high concentration area. As it goes up towards low concentration area, which means there's no bromine there. Okay, there's no molecule of bromine there. That's why bromine wants to go there. So they ask, why does this happen? Now, your answer will be as such. So you got A, B, C, D, right? So the first one, bromine vapor is less dense than air. Answer A is wrong. How do you count? You go to periodic table. You go to periodic table, you will realize that bromine is actually heavier than air. Okay? So A is wrong. Now B is saying that bromine molecules and molecules in air are always moving around. Okay, that is correct. This is what we have learned, okay, in the chapter of kinetic particle theory. We have learned that molecules in air, all right, they always take on constant random motion. And the key word over here is because of this constant random motion, what is going to take place is that the bromine is going to diffuse. That is why bromine can move in all directions, because it keeps getting hit by all the different air particles. So imagine one particle of bromine, it go here, it gonna hit by one air particle, it change direction, go up, change direction again. And that's the reason why the bromine will spread throughout the whole covered glass jar. All right. Okay, now the size of the molecules, actually this is incorrect as well, okay, because molecules of air is actually bigger, smaller. Bromine molecule are actually very big, okay. Bromine molecule, how do you know the size of a molecule? Remember, in your periodic table, you go all the way down to your periodic table, you will realize, okay, oops, okay, you realize that the location of the element on the periodic table tells us how big the molecule is. On top is small molecule. As we go down, number of electron increase, number of proton increase, the size of molecule increase, right? Mass of molecule increase. So you can see bromine is over here. Air, which is predominantly made of nitrogen, is on top. Okay. Okay, let's move on to the next option. Okay. Molecules move faster than molecules in air. Now, the speed of the molecules, as mentioned, because particles are always moving at random motion, constant random motion. So we cannot say that one particle is moving faster or one element is moving faster than another one. Okay, so answer for this question is B. Now let's look at question number 3. Okay, now we are, okay, this one is an interesting question. Okay, this one is an interesting question. Now, first we have aqueous silver nitrate. Okay, now if you don't know the formula, please know that AgNO3, okay, because it's Ag plus, NO3 takes on a negative charge, hence it's AgNO3. It's added to barium iodide, so it's Ba2, okay, because Ba forms 2 plus, okay, I form I minus, so 2, until no more precipitate form. So you are telling me what kind of reaction is this? Can you tell me what is the name of this reaction? Type to me in the chat. Anybody have any idea? Okay, yes, okay, displacement, okay. What is the result? What is the result? The result is where we will get precipitate, right? Okay, so this kind of reaction, okay, is displacement of ions, yes, to form a precipitate. So most of the time, we will call this a precipitation reaction. Okay, so let's write the equation for this. Very simple. We have AgNO3. Okay, this is aqueous, remember, because it's aqueous. Now, when we are doing precipitation kind of reaction, what is the principle? This is a way for us to produce a precipitate, which means that you can see over here, I first have 2 aqueous solution. Now, when I have 2 aqueous solution, what do? I pour them together. Now, remember salt preparation, we also learned about precipitation. Okay, this is a flask or it's a beaker. We will pour the 2 aqueous solution over here. What we will observe is that there will be some cloudy precipitate that is being formed. And this precipitate is a solid. Okay, so solid over here. And most often than not, we will realize that the other solution that is being formed is a solution, or the other compound that is being formed is a solution, is an aqueous solution. Okay, and that's why we can do separation to either get out this solid or get out this aqueous solution. All right, so I've just explained to you how does precipitation reaction work. Now, BaI2, this is an aqueous solution as well. It's going to give us what? It's going to give us, remember, displacement reaction, ionic exchange. Silver go to iodine. Barium go to nitrate. So this will be the result that we get. We have first getting barium nitrate. Okay. And we will also get silver iodide. Okay, so balance the equation, it will look something like this. Now, can anybody tell me which one is the precipitate, which one is the aqueous solution? Anyone have any idea? Which one is precipitate, which one is aqueous solution? Definitely, I have one that is precipitate because they tell me precipitate is filtered off. And to be able to filter something, the other one have to be a solution. Okay, good. I see one answer. Silver iodide is a precipitate. Yes, you are right. Okay. Now, silver iodide is the precipitate. Okay, because why? If you don't know there is a precipitate, so just remember barium nitrate. Barium all nitrate are soluble. Because it's soluble, it is in aqueous solution. Okay, so silver iodide is the precipitate. Now, you need to also know silver iodide is a yellow PPT. Okay, now I'm going to write down for you. This one is quite important as well. Precipitate of halide. So I have silver iodide, I have silver bromide, and I have silver chloride. Now, silver chloride is white color. Silver bromide is cream. Okay, and silver iodide is yellow. Okay, must know this. This one is also important. Okay, Okay, so this question, it tells you about this thing called the precipitation reaction. Now, can you see over here that they say that the precipitate is being filtered off? So I'm going to color code for you. The AgI over here is the precipitate. Now, filter off, okay, and what forms the filtrate? Now, this barium nitrate forms the filtrate, okay? This barium nitrate forms the filtrate. Now, can you see over here that the next reaction they tell us is that I need dilute sulfuric acid. I will add the dilute sulfuric acid to the filtrate. So this is a two-step reaction. Now, first step is where I have silver nitrate added to barium iodide. Now, this is the step number one of the solution where I produce one precipitate. Now, step number two, I take the dilute sulfuric acid, which is H2SO4. Remember, dilute sulfuric acid is aqueous. I add it to barium nitrate. KNO3, 2. This is also aqueous. Now, what is going to happen? Remember, displacement reaction, precipitation reaction, they are always an ionic exchange. Identify the ions present. We have H2, we have Ba, we have SO4, SO4, and we got nitrate. So whenever displacement reaction happen, they will just swap their ion, right? So you can see over here, the H2 will go to NO3, and then the SO4 will go to barium. So what is going to happen? First, we're going to get BaSO4. Second, we are going to get HNO3. So if you balance out, it looks something like this. So there'll be 2 moles of HNO3 that is produced. Okay, now you realize over here HNO3 is a dilute nitric acid. Okay, this is where I actually managed to convert a sulfuric acid into nitric acid through this kind of reaction. And in this case, they say that there will be another precipitate that is formed. Clearly, based on these two, you know that the BaSO4 is the precipitate because this one cannot be precipitate, Nitric acid cannot be precipitate. This one is the precipitate. All right, so what happened? Precipitate is filtered off. This is a solid. This is a aqueous. Okay, now BaSO4 barium sulfate. Now you need to know that this is a white precipitate. Okay, this is a white precipitate. Most of the time, when it's not transition metals, when it's metals that belong to a certain group, okay, a confirmed group number that is not within the transition, which means group 3 all the way until group 12 or 13. Now, you can know that since this is the case, most of the time, if let's say they are either group 1 or group 2 metals, they will form white precipitate. Okay, they will form white precipitate, colorless precipitate. Okay, they are colorless compounds. They form white precipitate. Now, So we can see over here, we are looking at the options. First one, both precipitate are soluble in excess aqueous sodium hydroxide. In this case, answer is no, right? Because you can see over here that for this silver iodide, okay, silver iodide, as well as the barium sulfate, we have never learned a reaction that can allow us to react either a sulfate, okay, or an iodide with a base, okay, to get a reaction. And because moreover, this is a solid, this is a precipitate, okay, this is a precipitate. Now, next, both precipitate are white. No, this one is wrong because we have already discussed that silver iodide is yellow color. Okay, it's a yellow precipitate. Effervescence is observed in the second experiment. Okay, second experiment, we are doing a precipitation reaction as well. Is there effervescence? Now, I want you to be very, very clear. What is the difference between effervescence and precipitate? Now, precipitate, remember, precipitate is a solid. The outcome is a solid. You will get a solid. Effervescence, okay, is just the chemistry way of saying they are bubbling. Okay, which means that, for example, I do a metal plus acid reaction, I get salt and hydrogen gas. Okay, I will say that effervescence is observed because why? There's bubbling effervescence of hydrogen gas. So most of the time, effervescence is used to refer to gases. This you must be very, very clear. Okay, effervescence is always used to refer to gases. Okay, so for this, all right, option C will be out as well. Last one is correct because HNO3 is produced. Okay, so option D is the correct answer. All right, any question? Can Okay, if I'm too fast, please let me know. If I'm too slow, let me know also. Okay, can go faster or stay at this pace? Stay at this pace, can give me thumbs up. Or if you want me to go faster, you can type in the chat. Or if you want me to go faster, you can give me a thumbs up. Anybody? Alright, everybody. Today Labor Day. Sorry, not Labor Day. Today Visa Day. Okay. Okay, Ken. All right. I think most of you can go a bit faster. Okay, let's go a bit faster. Now, this question, okay, we're gonna go slightly faster. Okay. I'm planning to cover at least half of the questions today. Okay. Which means up to question number 20. Now, this question is a question that is quite interesting. I think most of you, you will see some questions like this in your prelim exam, right? So this question is talking about the valency of electrons, right? Number of valence electrons of an atoms plotted against its proton number for the first 10 element of the periodic table. Now, this kind of question is very common for schools that would like to test the first few chapter. And why do I say so? Now, you must be able to recognize that the reason why they're asking this question is that you need to know that the first electron shell can only hold 2 electrons. The second electron shell can hold up to 8 electrons. So with this understanding, you need to know the proton number. In an atom, the proton is always equal to the electron, right? So with this understanding, if I have 2 electron, 2 proton, I will have 2 electron. That is correct. 2 electron in the outer shell. Now, if I have 4 proton, I will have 4 electrons also, right? But is this 4 electron going to be at the outer shell? Answer is no, because the outer shell now have only 2 electrons, 2, 2, because this one is full already. So it changed back to 2 electrons. Okay, so you will notice that proton number 2 and proton number 4, the elements, they all have number of electrons equals to 2 over here. Okay, so if you don't believe me, look at the periodic table. So proton number 2, okay, this is 2. This one will be 2, 2. All right, and lithium will be 2, 1. So there's only 1 valence electron. So you can see over here for this question, option C is correct. Okay, option C is correct because, for example, lithium is 3 it only have one valence electron. So this one is, well, for students who need to be able to recognize this kind of pattern. All right. Now, D is obviously out of the picture. B also obviously out because it is clearly not the case. When it is increasing proton number, the number of electron actually shouldn't be decreasing, must go up. Okay, so this is for question number 4. Now we move on to question number 5 and 6. Now, question number 5 is a question that is talking about a compound. Now, nitrogen forms ionic compound with element X. Now, you do know that since this is a situation whereby this is ionic, X is a metal. So these tiny little clues that the question gives you, you need to be able to know. Okay, if they say ionic compound, you need to know, since nitrogen is a non-metal, element X should be a metal. Now, because it's like that, nitrogen is in group 15. It forms a charge of 3 minus, okay, oxidation state of 3 minus. So in this case, I have 2 minus 3, and that means that the oxidation state will be 3 bracket plus 2. So you can tell that over here that X have an oxidation state of plus 2, which means it belongs to group 2. Right, so it belongs to group 2. That means that X will form an ion of 2 plus. Okay, so what formula of compounds formed by X is correct? Clearly, number 1 is out because oxygen will always form O2 minus. That means that the charge is imbalanced. This one, sulfur also same thing. Okay, it will not form a charge that is balanced. Now, this one is the correct one, right? Because fluorine is F minus. So which means if I have 2 fluorine and 1 X2 plus, it will be able to cancel away each other, right? So this one is your correct answer for question number 5. Okay. Now, for option D, okay, option D is also wrong because you know that X is 2 plus. So this one becomes plus 4. Okay, be O2 minus. Okay, also wrong. Yeah. Okay, now question number 6. Try this. Can you tell me what is the answer? They are quite simple. Anybody have any idea? Question number 6. Both ionic and covalent. This is a very common question as well. By the way, if you have any questions, you can ask. Okay, I got one person choose C. Somebody choose A. Okay, another person choose A. Okay, let's go through. Now, ionic and covalent bonds. So what does that mean? If I have a compound that contains both ionic and covalent bonds, that means that most of the time I'm looking at a complex ion. So you can see, if let's say I have a positive ion and a negative ion, now definitely because I need one ionic, one covalent, definitely it will be one of it, right? One of the ion must be like maybe something like there must be a bond. There must be a bond that is being formed. And then the overall charge of this is plus. Or it can be overall charge is minus. Okay, I just writing random ion so that you can see. Now, so you can see over here, first one, ammonium chloride. So ammonium chloride is NH4Cl. If I were to put in the plus, it will be NH4 plus Cl minus. Now, so you can see over here, this is clearly the one that I'm trying to tell you about. I have N that is connected to 4 hydrogen, and overall, it will have a positive charge. Okay, overall, you have a positive charge. So we can say that this one, because the NH4, they are connected through the sharing of electron, we will say that they contain covalent bonds. Now, by the way, do you all know why it's called covalent bond? Okay, covalent bond, right, come from the term co is sharing. Okay, sharing. Now, valent is referring to valence electron. So you can see the term covalent bond simply means the sharing of your valence electron. That's the reason why the term covalent bond come up, right? Okay, so just for your knowledge, in case you don't know why it's called covalent bond, why we always say covalent bond is because it's a sharing of a valence electron, valence shell electron, all right? Now, so this is for A, so Cl minus. So you can see this positive and negative, this is ionic. Ionic is always electrostatic force of attraction. So option A is correct. Now, option B is carbon dioxide, clearly out because this is a covalent molecule. Okay, there's no ions involved. Ethyl ethanoate. Now, ethyl ethanoate is something that is a bit special. Now, this one over here, okay, what is ethyl ethanoate? Okay, ethyl ethanoate is when an alcohol, okay, this in this case is ethanol, okay, react with a carboxylic acid, which is ethanoic acid. Now, this will form what we call, okay, what we call an ester. Now, this ester is over here. It is an organic compound that have no charge as well. Okay, so it's a completely covalent substance. So answer is no as well. Sodium sulfide, it is NaS. Okay, there's no there's no there's no covalent bonds as well. Okay, there's no covalent bond as well. It's all ionic. Okay, Na plus sulfur, probably -2. Okay, now I'm going to go to question number 7. Okay, before that, any question for question number 6? I know that some student have just joined or left again. You're not to worry. Just wait for him to come back. Okay, now let's look at question number 7. Now, when a covalent liquid boils, its molecule become very widely spaced. Now, when the question tells us this as the first statement, you must be able to know something. They tell you that it is covalent liquid, the molecules become widely spaced. Okay, before that, okay, I have a question for Kaisi. Okay, does not need to be an ionic compound to have an ionic bond. No, it needs to be an ionic compound. Yeah, ionic compound contain an ionic bond. So you can see ammonium chloride because it's positive and negative. So the ionic bond exists here. Whilst ammonium chloride also got covalent because covalent bond exists between nitrogen and hydrogen in the ammonium ion. Yes, okay. Ionic compound is metal plus non-metal. That's why we say usually ionic compound is metal plus non-metal. Ammonium ion, NH4 plus. This is a positive ion. Cl minus, this is a negative ion. When ammonium and chlorine, they bond together, they form an ionic compound, which is ammonium chloride. Okay, so ionic compound, yes, generally we say that they are metal plus non-metal, but ammonium is an exception. Ammonium form a positive molecule. Can so sodium sulfide is a normal one because we have positive metal ion, negative non-metal ion. Can yeah. Okay, later I repeat again. Okay, if you don't understand. Now let's go to question number 7. Now, covalent liquid bonds, its molecule become very widely spaced. Now, as I was saying, this question, they are trying to tell us something. When there are molecules that become widely spaced, they are talking about what kind of substance? Are they talking about simple covalent structure or are they talking about giant covalent structure? Can anybody tell me? Is it a simple molecular structure or is it a giant molecular structure? In this case, when they say covalent liquid boils, its molecule become very widely spaced. If you think it's simple molecular structure, type SMS. If you think it's giant molecular structure, type GMS. Type inside the chat. Okay, somebody say simple. Okay, somebody say GMS, giant molecular. Okay, somebody say simple. Anyone have any other idea? Okay, so for this question, what they are trying to tell you is it is a widely spaced, which means I got 1 molecule, 2 molecule, 3 molecule that have weak intermolecular force of attraction. Right? Because I boil, I weaken the intermolecular force. Hence, in this case, we are talking about simple molecular structure. And you need to be able to understand this. So the question is already hinted to you, okay? Already hinted to you that it is a simple molecular structure. Now, hence they're asking which property of the molecule have a most influence of the energy to boil a covalent liquid. So first one, the force of attraction between the molecules. So that means if I have one molecule over here, another molecule over here, the force of it over here. Now, This is number one, option A. Option B, the reactivity of the molecule. Now, when I see option B, immediately it's out already. Why? Because it is a covalent substance. Covalent substance, we never talk about the reactivity, right? Reactivity of the molecule is when, let's say, I have two substances that are put together, right? Okay, either they are acid base or they are combustion reaction. But most of the time, we don't talk about molecules reactivity, right? To be influenced on the energy required to boil a covalent liquid. So this is wrong. The shape of the molecule also does not matter. Okay, not say does not matter, but it's insignificant. The strength of covalent bonds in the molecule. Now, this one also possible. So we have A and B as the possible answer. Now, but we need to see clearly what kind of attraction that we are trying to break or overcome. Now, I'm going to give you a simple example using water as a simple molecular structure, and we are going to discuss, okay, how does it work? Now, can everybody understand? If let's say I have two water molecules over here. Now, number one, between the OH and the hydrogen, there over here, it exists a strong covalent bond. Does everybody understand this? Because it is between an atom as well as its neighboring atom. Now, they form strong covalent bond between themselves, between the atoms, okay, among the molecule. Now, between each molecule, what exists between them? This one over here is what we call the weak intermolecular force of attraction. This is what we call the weak intermolecular force of attraction. Now, students always confuse these two. This is a strong covalent bond. Now, the one they are highlighted in red color, this is a strong covalent bond, which means this one, okay, is very difficult to break. I need high temperature. Whilst this over here is the weak intermolecular force. So how does it actually work? When I link back to kinetic particle theory, solid, they are closely packed in an orderly arrangement. This is solid. Liquid, they are closely packed but in a disorderly arrangement. In the gas, they are far apart. Now, this is exactly what we are talking about over here. Now, can you see over here? In the solid state, this is a water molecule, this is a H2O. Between each molecule, there exists a very strong, weak intermolecular force. My keyword over here is the weak IMF is very strong. A bit contradictory, I know, but we compare. Why is it that I say strong over here? I'm going to compare to the liquid and the gas. Okay, now next, because when I supply some heat, can you see that the intermolecular force over here is slightly overcome? So hence, there is slightly more space between each of the molecule. So this is a weak intermolecular force, which is correct, but it is not so strong. Okay? Now, can you understand that if I heat this even more, if I supply more heat, can you see over here that now the weak intermolecular force is very weak? It's almost non-existent because I already broke away all the weak intermolecular force. I supply so much heat that they are no longer attracted to each other. That's why they can move in all directions that they want. So can you see weak intermolecular force, you can link it to the concept of solid, liquid, gases. Okay, the states of matter, the three states of matter. All right, so I need you to be able to understand this. So in the solid state, the weak intermolecular forces between the water molecule are the highest, the strongest. Then when I supply some heat, the weak intermolecular force become a little bit more weaker, right? And then when I supply even more heat, it becomes super weak. Okay, the force is like not existing like that. Okay, so this is for this part over here about the solid, liquid, and gas. So you can see over here, I am looking at the atoms. I'm looking at the molecules. Okay, so you can see this is a water molecule, H2O. This is still a water molecule. Now, can anybody tell me, in this case, when I'm converting something from a solid to a liquid to a gas, is any point of time my strong covalent bond broken? Is it broken? No, not broken. Anybody do not understand? Okay, it is not broken. So the water molecule stays intact. It stays intact. Okay. the strong covalent bond between the hydrogen and the oxygen is never broken. And hence, can you see over here? What I'm trying to tell you is that the strength of the covalent bond in the molecule does not matter for its boiling point. They are asking about the boiling point required to boil a covalent liquid. So the only possible answer for this is option A, or the most appropriate answer for this is option A. Okay, okay, let me move on. Okay, question number 8. Now, this one requires you to do some calculation. Can we try question 8? Try and calculate, and then you let me know your answer in the chat box. Okay, you try and calculate for question number 8. Meanwhile, I'll leave question number 7 working up. So in case you like to copy it, okay, give it 2 minutes, you try this. Now, I guess you are on question number 8. Okay, you can download from Telegram, and then you can try question number 8. Okay, good. I see another answer. Thank you. I also saw an answer. Okay, so for this question, how do we do? I think some of you are correct. Some of you maybe are slightly careless. Okay, so let's look at this. Now, 71 gram of chlorine gas. First, we calculate number of moles. Okay, now number of moles of chlorine. Now remember, chlorine gas is Cl2. So how do we do? 71 divided by 35.5 multiply by 2. Sometimes students forget this, the multiply by 2 part. So once you get this already, you'll realize that it is 71 over 71, which is gives you 1. So there's 1 mole. Now, in 1 mole, okay, 1 mole of phosphorus vapor, okay, is 124 gram. So in this case, what do you think is the formula for the phosphorus? Now, you go back to your periodic table, look at the mass of phosphorus. Okay, phosphorus is over here. It is 31. Mass of phosphorus is 31. So for me to be able to get 124 grams of it, I need to multiply by 4, right? So in this case, for every 1 molecule of the phosphorus, for every 1 molecule of phosphorus vapor, there will be 4 atoms. Okay, 4 phosphorus atoms. And hence your answer for this question will be option C. Okay, so this is for phosphorus. Okay, now I hope you are okay with this question. Now let's go on to question number 9. Now, mole of chloride is 74.5 grams. What is the formula of the chloride? Okay, so 1 mole of the chloride is 74.5 grams. So that means, remember how to find MR? Formula for MR? Type to me in the chat. What is the formula for MR? Remember your mole triangle. Okay, good. Mass. Yeah, by mole. So in this case, very good. So mass is 74.5 divided by 1. So the MR is 74.5. So very simply, you can see over here, since chlorine means got a Cl minus, right? So Cl minus chlorine atom is going to be 35.5. Right, so 74.5 minus 35.5, you realize that the answer is going to be what? Is it 39? 74.5 minus 35.5. It's going to give you 39. Okay, so 39 is the mass of the other metal, right? The other metal. So can you go to the periodic table and find, is there any metal that is 39? Okay, 39 in mass. Yes, you will find one, right? Potassium. Potassium is 39. 39. So you know that it is going to be a KCl. So you can see the formula, very simple. Option will be option C for question number 9. Okay, 1 mole of the metal and 1 mole of chloride makes up the compound. Okay, okay, question 10. Now, this is one question that is quite interesting as well. Just for your knowledge, is on energy changes or energetics. Now, sodium hydroxide and hydrochloric acid. Now, first off, sodium hydroxide and hydrochloric acid, it is an acid-base reaction. Now, acid-base reaction, can anybody tell me, without looking at the enthalpy change, is it going to be an exothermic reaction or endothermic reaction? Acid-base reaction. Anybody have any idea? Okay, good. Kaiji said exo. Okay, Thank you, Hiwan, also. Yes, you're right. Exothermic reaction. Okay, so remember, base and acid-base reaction always produce heat. It is an exothermic reaction. So when it produce heat, the energy level will drop. The energy level of the reaction will drop because energy lose heat to surrounding, or reaction lose heat to surrounding. Now, so you can see, whenever we look at this, it's always H plus plus OH minus. Acid-base reaction, the ionic equation is like that, and you will form water. Okay, so the enthalpy change of this reaction for 1 mole of the reaction is negative 54 kilojoule per mole. Okay, now what is the energy given out when 100 cm cube or 1 mole react with 100 cm cube or 1 molar sodium hydroxide? 1 mole per dm cube, concentration is 1 mole per dm cube. So you can know that when you calculate this, it will be 0.1 mole of HCl. Okay, react with 0.1 moles of water. Sodium hydroxide, NaOH. And because the ratio is 1:1, can you see over here that there will be 0.1 mole of water that is being formed as well. So if there's 0.1 mole of water being formed, 0.1 mole of the reaction has taken place, then this is per mole, right? So to get 0.1 mole, what do? I divide by 10, right? Because I times 0.1. So I take this times 0.1, it will give me negative 5.40 kilojoules. So this will be the enthalpy change for that reaction. Okay, for that reaction, 0.1 moles of HCl reacting with 0.1 mole of NaOH. So you can see over here, very simple, because it is energy change or enthalpy change, that tells us whether it is a drop. The positive and negative, now you must always remember this is important also. This always tells us, the positive or negative tells us the direction of heat transfer or energy transfer. This is important. Okay, whether the energy is going out of the reaction or whether the energy is going into the reaction. If it's positive, it's going into the reaction. If it's negative, it's going out of the reaction. Now, with this understanding, what I'm going to do is that I'm going to use that as an answer because the question say given out. Now, if the question say given out, my answer will going to be positive, right? Because given out, we give out a positive form of energy. Remember, the negative sign is always the direction. So you must be very careful when you're reading, okay, reading the question. Okay, so if let's say the question say, what is the enthalpy change? If it say enthalpy change, then it's negative 5.40. Okay, if it says energy given out or energy release, it's just 5.40. Okay, so this is for question number 10. Ken, any question? Can I? Okay. So every question, I will just try and emphasize some of the important point in case that you need to know for the exam, okay? In the common questions that exam will give you. Now, this one is the question that many students don't always look at this chapter. It's on isotopes. Okay, it's on the mole concept and isotopes. Now, isotopic composition of an element. Okay, isotopic composition of an element is indicated below. Hi Clarice. So for the Telegram, you need to go to the Telegram to get the worksheet. Okay, so you just download from Telegram. Then after you can follow. We are on question number 11. Okay, now let's go back to question 11. Banana. Ionic composite of the element. Sorry, Clarice. Okay. Oops. Okay. Okay. Now, isotopic composition of an element is indicated below. Now, what is isotopic composition? Now, that means different atoms of an element, they can have different masses. And that is the reason why chlorine, the mass is 35.5. Because 70% of Cl have a mass of 35. Okay, and the other one, they probably have 36 and 37 as well. So on the average, it came out to be 35.5. So this is for chlorine. So every different element, they definitely will have some form of averaging. And that is the reason why we study these terms called isotope. Now, relative abundance, that means how many percent of it has the mass of 10, how many percent have a mass of 11, etc. Okay, so if we look at this table, the relative abundance, so you imagine there's one atom that have 10. Okay, The other atom, there are four atoms, okay, 11. The next atom also 11. So there are four with 11. And then there is zero. Okay, there is zero with 12. Okay, so this one don't have. 9 also don't have. Okay, so this line represent how many they have, right? So you can see, you follow this number lah, huh? Okay, so you can see, what I'm going to do is that I'm going to take everything I add together, 10 plus 11 times 4. I'm going to divide by the total number of molecule I have over here. In this case, I got 1, 2, 3, 4, 5. So divide by 5. And then the answer they give me is 10.8. Okay, so answer is option C. Can? Give a question number 11. Okay, so this one you must know as well. Isotope. All right. Okay, next. Question number 12. Solid nitrate fertilizer. Okay, now solid nitrate fertilizer, first thing you need to understand. Fertilizer is for plants, right? So solid nitrate fertilizer, it needs to contain NO3 minus. It reacts with an alkali. It reacts with an alkali. Alkali to produce a gas which turn immediately. Can anybody tell me what is the identity of this gas? Good. Fantastic. Anybody have answer? Okay, Kaiji, good. Anybody else? Okay, I'm asking for this. Okay, damn red litmus paper blue. What is the identity of this gas? When they say gas which turn damn red litmus paper blue, there's only one that we study. Okay, Melissa, you're right. It's a alkali, but what alkali? Good, fantastic. Okay, so in this case, we are looking at ammonia gas. Okay, now we must always remember this. What kind of reaction will give us ammonia gas? Now, when there is an ammonium compound, if I have an ammonium compound, this one you need to know, acid and base chapter. Ammonium compound react with alkali. Okay, it will produce ammonia gas. This is important. So with this understanding, they are asking us what is the empirical formula of this fertilizer. Now, empirical formula is the simplest ratio of each element to its quantity. So that means what? It means if let's say my element inside, my compound inside got 3 moles of nitrogen, so it'll be N3. I got 2 moles of hydrogen, it'll be H2. I got 1 more oxygen, something like that. Okay, so basically, it's talking about what is the ratio between each element, okay, in the compound itself. So there's no order that they arrange. So you can see over here NHO3. Basically, it's just listing out what elements that are present inside this compound. Okay, now option A is definitely immediately out because you know NO3. NO3 is an ion, it contains a negative charge. It cannot be neutral. Okay, it cannot be a solid fertilizer. Now, next, B, HNO3. So you can rearrange this easily. You'll realize it's HNO3. HNO3 is an acid. Now, acid react with base, right? If let's say HNO3 react with alkali, it will not produce you ammonia gas. Why? Because acid plus base give you what? Give you salt and water. Remember, acid plus base give you salt and water. So B is out also. Now, C then NH2O. Okay, NH2O, okay, actually it turns out NH2O is not even element, okay, of a fertilizer, or rather it's not even a compound, right? So what is the actual compound? Actually, it's over here. Okay, so how do you know? How do you know? Because I need ammonium compound. Ammonium compound needs to contain NH4 plus. So in this case, this NH2O don't have 4 hydrogen for me, so cannot. This one have. So this is NH4 plus. What is remaining? NO3 minus. Can you see? This is ammonium nitrate. Ammonium nitrate fits the bill. It forms a solid nitrate salt, which react with alkali to form ammonia gas. Okay, so option D is the answer. Do you need me to explain this question again? Anybody have any question? Need me to explain, can give me a thumbs up. Anybody not clear? This one you need to remember your reaction for the chapters on acid and base, okay? Can Okay, nobody need me to explain again. Okay, now this one is an interesting question, electrolysis. Now, a apparatus shown was used to set up a copper plate to copper plate a metal spoon. So that means what? That means I want copper to be able to be plated on the spoon. Okay, so I want the spoon to be coated with copper metal. Now, can you look at this question? First off, whenever you approach electrolysis question, I'm going to teach you, or I'm going to remind you, if you are my student, I'm going to remind you the same approach that I've taught you like 100 times already. Now, how to start an electrolysis question? First, always identify positive and negative terminal. Positive and negative. Longer for positive, shorter for negative. When you know the positive and the negative, bring it down. Bring it down. So it's positive, negative. Now, the first step done. Second step, identify which one is the anode, which one is the cathode. If you cannot remember, just imagine if I have a positive ion, is a cation ion, it will go to here, right? So cation ion go to cathode, C. If I have a negative ion go to here is positive. Negative, we call anion. I call this the anode. Step number 2, settle. So very, very important. You must always know this. A and C is your second step. First step is always positive, negative terminal. Okay. Now, once you're done with this, third step, remember, is always to identify what are the ions present in the solution. So in this case, because it is a solution. Now, keyword over here, solution. Solution means what? It contains water. Contains water. Well, many of these questions, they would like to give you little clues like this. Little clues like this that you might or might not be able to pick up. And it is important for us to realize that these clues can actually change what the question is trying to tell us. If we did not manage to pick up such clues, what you will mean is that you will get misled by the question. You will think that there is no water present. You will think that there is a separate outcome that is going to take place. Okay? Now, contains water, which means what? I have Cu2 plus. I have SO4 2 minus. Same time, I got H plus and OH minus. So in this case, I'm considering there are 4 ions. Okay. Now, can you see over here what happens? Now, they tell us that the experiment cannot work. Why cannot work? Now, imagine, so Cu2 plus SO4 2 minus H plus OH minus. For me to be able to electroplate the spoon, I need the copper 2 plus to be able to go to the spoon. So in this case, immediately cannot, because 2 plus cannot go to the positive terminal. They will gonna repel, right? So in this case, this setup don't work. Why? Because the spoon should be the negative terminal. So what is this trying to teach us? It is always correct for us to put the electroplated object or the object to be electroplated in that case, sorry. Object to be electroplated. Can I just clarify myself over here? Put the object to be electroplated at the cathode. This is 100 times more important than you think. Because many times students forget this. Forget that it should be at the cathode. And then they will blindly put it at the anode. Then they will realize that the ion cannot go there. And then they will realize, hey, I only got 5 minutes left. What is wrong with my drawing? I cannot tell. Then that's where they start to lose mark. Okay? Now, so you need to know this. Put the electroplated, the object to be electroplated at the cathode, which is the negative terminal. Okay, so this is the main take-home message you should have for this question. All right. Okay, so in this case, then the answer is here. D is the answer. The spoon should be the negative electrode. Okay. A, no, I need copper. Copper to be in the solution. A is not correct because disulfuric acid does not contain copper 2 plus ion. Okay, B, molten copper 2 sulfate should be used as an electrolyte. It doesn't change anything because the spoon is still going to repel away the positive copper ions. C, the battery should be replaced with a voltmeter. Now, can anybody tell me when is it that we need to use a voltmeter instead of battery? What is the one simple application that we need to use a voltmeter? instead of battery. Okay, good. Okay, simple cell. That is the only time. And simple cell, once again, if you're my student, I say don't know how many times already. It works on the basis of different reactivities of metals, right? Two different metals with different reactivities. So if let's say that the two metals are unable to generate a current by itself, me replacing it with a voltmeter will not change anything. Okay? So this is question number 13. Let's go on to question 14. Now, question 14, we are doing electrolysis again of concentrated sodium chloride this time. The products, they tell us that it's a chlorine, hydrogen, and sodium hydroxide. Now, the maximum yield of chlorine and hydrogen with 58.5 grams of, kilograms of sodium hydroxide is electrolyzed. Let's try this question. Okay, work on this question. Find an empty space, write down your workings for this question. I want to see whether you know how to apply the formula to do the question. Okay, can I go through? I go through, Okay. I think some of y'all are thinking a bit too much for this question. We go step by step, okay? Now, in an electrolysis question, the most important fundamental thing is for me to get the framework out first. So, first, I will draw my electrolysis setup. Okay. In the event you don't know how to start the question, always visualize first. Okay. Humans, you and me, we are all visual creatures. We like to look at drawing. So first we draw. All right. Now we must first understand. Okay, everybody, look here. Now we must first understand that this is concentrated NaCl. Now, which means what kind of ions does it contain? It contains Na plus, contains Cl minus, contains H plus, and OH minus. Okay, now we have positive terminal, negative terminal, anode, cathode over here. Now, first, we must understand at the anode, what is going to happen. Anode is where the negative ions go there. This is a situation whereby I have Cl minus and OH minus fighting. So is it Cl minus will be discharged or OH minus will be discharged? Because this is a concentrated solution, Cl minus will be discharged. Okay, so this is the equation, Cl minus in aqueous solution will discharge to form Cl2. This is a gas and electron. Then with that understanding, I go to the cathode. Okay, step by step, I always remember, we do chemistry question, we don't do all at one shot, we do step by step, okay? Step by step so that we can understand better. All right. So at the cathode, what happens? Na plus go there, H plus go there. Now, although this is a concentrated solution, you know that sodium is too reactive, so reactive that it will never be discharged. So hydrogen will discharge. Okay, so 2H plus will undergo discharge by gaining 2 electrons to give you hydrogen gas. Okay, so I know some of you are not familiar with writing overall equation. How do we do? Whatever that is on the left-hand side of the arrow, can you see? For these two reactions, I highlight in purple. Whatever that is on the right-hand side, I highlight in yellow. How do I do overall equation? I put whatever that is on the purple one side of the arrow, put whatever that is on the yellow or on the other side of the arrow. Okay, so I put 2Cl minus plus 2H plus 2 electron over on the left. Whatever that is purple, I put on the left. Whatever that is yellow, I put on the right. Can you see that? Now, can you see on the left-hand side and right-hand side, I got something in common, which is the electron. I will cancel away the electron. Because on the left have, on the right also have. Then what's the point? I don't put inside, okay? So I remove it for simplicity's sake. Now, next. After I gotten this, what I'm going to do next is 2Cl minus, simplify my equation. It's going to look like this. Cl2 plus H2. Can you see that? This is basically the equation that I just rewrite. No change, okay? I just rewrite only. Now, with this understanding, what I'm going to do now is that I have already achieved this one. I have already achieved the overall equation, right? I've achieved the overall equation that I wanted to get. Now, with this is very powerful because we can do our working later. Okay, this is a very good achievement. Now, let's come back to here. The number of moles of sodium chloride is 1,000. Okay, 1,000, remember that number. Now, when I come down to here, I'm going to find the space. Can you see over here? In this equation, my mole ratio is 2Cl, 2H plus will give me 1Cl2 and 1H2. This is my mole ratio. So whenever you remember, mole ratio or the stoichiometry is the ratio between the elements or the substances. But for me to find the actual number, I need to use the actual number, right? So NaCl is 1000. Now, can you see if I have 1 mole of NaCl, I will have 1 mole of Cl minus. How do you know? NaCl give you Na plus and Cl minus one. 1, 1, 1. Can you see that? So the ratio between NaCl and Cl minus is 1000 is to 1000. So this is an actual number of moles. Actual number of moles that I'm carrying out the electrolysis with. So hence, this will become 1000 Cl minus plus 1000 H plus. Can you see that? Because the ratio need to be the same, right? Because 2 is to 2 become 1000 to 1000. So the amount of Cl minus that they produce is 500. Sorry, Cl2 that they produce. And it will also produce 500 H2. Can everybody understand this? If you understand, you can give me a thumbs up. This is based on the mole ratio over here. If you understand this, give me a thumbs up. Oh, you already lost me already. Okay, Kaisi get it. Very good. Melissa, he won. Okay, Marilyn, okay, huh? Okay, good. So I got 500 moles of Cl2, 500 moles of H2. Okay, fantastic. Now, after I have this, what do I do next? I got 500 moles of Cl2. Cl2, this is Cl2, 500 moles. H2, I also got 500 moles. So what do you want me to find? The question want me to find what? The question want me to find what is the U of hydrogen and U of chlorine. So very simple one. U of hydrogen, U of chlorine. I take 500 multiplied by the MR. So this is 35.5. Then this is 2, right? So it will give me what? It will give me, sorry, wrong. This is 35.5, but multiplied by 2. So you must multiply the whole thing by 2. Okay? So you should get a number that is 3550, and you should get a number that is 1000. Do you all manage to get this? Okay. Now remember, whenever you are working with moles and MR, they will always give you in grams. So the question say it wants it in kg. How do I convert? I divide by 1000. So if I divide this by 1000, it will give me 35.5 kg, and this one will give me 1 kg. Okay? Sorry, there's one more zero over here. Forgot. Am I right? I think I'm right. Okay? Any question? Understand? Understand? Give me thumbs up, okay? So that I know that you understand. I will scroll down. Okay, let you see this. Answer should be A. Apple. Yeah, okay, good. Marilyn, good. Melissa, good. Okay, good. He won also, okay? Can Margesh, okay? Margesh should be quiet also. I see, I think can. Okay, good. Let's go. Next question. Question 15. Okay, now let's look at question 15. We are doing electrolysis again, right? A lot of people hate to do electrolysis because very difficult to do. But because precisely it's very difficult to do, very easy to lose mark, we need to know how to do so that when people lose mark, we gain the mark, okay? Now, electrolysis or molten lead bromide solution with inert electrodes connected to external battery. Okay, now, first thing, molten lead bromide solution. Because they didn't give you which is a positive, which is a negative electrode, first thing for us to do, we just skip that step first. Although, yes, we can look at this and then we can deduce which one is what. Okay, simple. First, we find out what are the ions in the solution. In this case, it's Pb2 plus and Br minus. Anything else? Don't have because this is a molten solution. Okay, molten substance. Molten substance means no water. Okay, get me so far. Now, because Pb2 plus and Br minus are the only ones present inside here, what is going to happen? Can you see? They are going to undergo discharge. This is going to undergo discharge to form lead solid. This is going to undergo discharge to form bromine gas. Now, bromine gas, it turns out this is a reddish brown gas over here. This one. Then can you see this is going to be the silvery molten metal that we see over here. Can I? Now, so how do you work out what is the positive or negative electrode? Can you see over here, Br2? Because it's a negative ion, the negative ion will come to here and then it will get oxidized, right? So this is going to be the anode. And if it's an anode, it's a positive electrode. The other side, because the positive ion go there, it's definitely going to be the cathode. So this is how you work out. Even if, let's say, the question did not give you the direction of the battery, you can still know. Can? Okay, with this understanding, let's look at the options. Which statement about the process is correct? New compounds are formed. Reddish-brown gas are formed at the cathode. Silvery molten metals are formed at the positive terminal, and the volume of electrolyte decreases over time. So which statement is correct for this question? Okay. Which statement about this process is correct? Okay, so you can see, yes. First statement, they are saying what? New compounds are formed. Okay, so when students look at this, they will think, okay, correct what? Because I am left form, I Br2 form. So they will normally put A as their answer, as new compounds are formed. But can anybody tell me what does compound mean? Define compound in the chat. Test you a bit. Element compound mixture. Define compound in the chat. Compound got anion and cation. That is ionic compound. Actually, you're right. Okay. Compound, no. Compound not anion and cation. Cation and anion is for ionic compound. Okay? Fantastic. Okay, Vanessa, you got it as well. Okay. It's made of two or more elements. Fantastic. Okay, so compounds you need to realize that it's made of two or more elements. So if students don't know or if they forget, this Br2, they think that it's a compound, they think that it's a compound. No, answer is no. They are all elements. They are all elements. Because this is the simplest element. This is also a simplest element that exists, right? Okay, second one. Second one, reddish brown gas is formed at the cathode. Clearly wrong. Because reddish brown gas is formed at the anode. This is what we have discussed. This is wrong as well. The silvery molten metal is formed at the cathode. Okay, it's a negative terminal. So answer is D. Okay, volume of electrolyte decreases over time. Why? Got Pp2 plus, got Br minus. Can you see as the reaction proceeds, the Br minus is removed from the molten solution. This side, the Pb2 plus also removed from the molten solution to form this silvery molten metal. So you can see the volume of electrolyte, which is the molten lead bromide, decreases over time. Can? I hope that you understand this part over here. Can? Okay, let's go now to next question. Okay, question number 60. Nitric oxide. Okay, nitric oxide and bromine vapor react together in an equilibrium reaction. So this question is testing about energetics again. You have a delta H, right? So you can see in this case, we are looking at nitric oxide reacting with bromine to give you NOBr. Okay, so NOBr forward reaction have an activation energy of 5.4 kilojoules per mole. Okay, so can anybody tell me this kind of question? What is the best way for us to do it? Okay, what is the best way for us to approach this question? Anybody have any idea? What is the best way to approach this question? Or how will you approach this question? Type to me in the chat. How will you approach this question? Sorry, yeah. Fantastic. You are right, Kai-Chi. Okay, Kai-Chi suggested a way, okay, which is possible. Anybody else have any idea? Okay, Kai-Chi suggests draw energy profile diagram. Oh, Melissa don't know. Okay, don't worry. Let's try. So they're asking us to find something that can help us to illustrate delta H and activation energy. So delta H is what? Delta H is enthalpy change. So what we're going to do, we are going to put here. Now, for simplicity's sake, right? Okay, for simplicity's sake, what I'm going to do is I'm going to, wait, let me draw this first. Let me draw the diagram first. Okay, good. So for simplicity's sake, I will name everything on the left-hand side as R. They are the reactant. Then I will name everything on the right-hand side as product, P. So that when I draw the energy change diagram or energy profile diagram, I don't need to write so many things. So first, I need to identify, since it is a negative delta H, it is going to be an exothermic reaction. So the total energy level, this is energy, this is progress of reaction, energy level is going to drop. First thing, I need to write down the delta H. This is the delta H. Okay. Next, because they are telling us that there's an activation energy. Now, activation energy always point upwards. It always point upwards. It always goes up because I need to overcome the activation energy barrier before I can proceed with the reaction. So, activation energy looks something like this. Okay, the energy profile diagram will do something like this. This is the activation energy. So this is for the forward reaction, reactant to form product. Now, what about the backward reaction? Because this is a reversible, how do you know it's a reversible reaction? You see this arrow over here, the double-headed arrow. This is a reversible reaction. So how do we know what is the activation energy of the backward reaction? Means I need to go from P all the way up. Okay. So remember, activation energy is like that. It's like taking a roller coaster like that. So my roller coaster is here. You need to go up the hill before it can go down the hill, right? So when you go up the hill, you need to take some energy. You need to absorb some energy so that it can roll down. Okay, so now my roller coaster is over here. I need to go up. So in this case, what is the energy I need to absorb first? So this is the activation energy. Can you see? The roller coaster need to go here. It need to go up all the way here. After that, then I release energy. So this is the activation energy. This one over here. Activation energy of the backward reaction. From P, I go into R. Can you see over here? Instead of from R, I go to P, now is P go to R. Okay? So in this case, what is the activation energy? What is the magnitude of the activation energy? So it's from here to here, right? So I got EA, which is what? Which is 5.4. And then I got 23.0. Now, whenever I do this kind of situation, I don't like to put the positive or negative sign because the positive negative sign when calculating is very confusing for me. So I just put the magnitude. So I recommend that you do the same thing. Just put the magnitude. Just put the number first. Later, we will figure out the positive negative. Like that, I put in 5.4, I put in 23.0. So I'm going to add these two values together. You will realize that it gives me an answer of 28.4 kilojoules per mole. Now, remember energy changes chapter, energetics, the direction of energy transfer is indicated by the positive or the negative sign. So the positive negative can be added in at the last part. So in this case, is it going to be positive or negative for this activation energy? Can anybody tell me? Going to be positive or negative? My roller coaster is here. I need to go up. I need to go up. So is my 28.4 going to be a positive or a negative? Okay. He wants to say positive. Kaiji say positive. Melissa say positive. Marilyn, I hope you are following also. Okay. If you have any question, can type inside the chat. Okay. So, yes, you are right. It's positive. Why? Remember, number one, activation energy must always be positive. Activation energy always point upwards. Okay. Why is it positive? Because I am gaining energy. Okay. Because I'm gaining energy. Now, before I lose energy, I need to gain energy. First, go up the hill, right? Okay. So, answer is D. D for donkey. Okay, lah. Okay, so this question, it help us to test quite a lot of things. It help us to know how to draw activation energy, energy profile diagram, help us to illustrate activation energy on the diagram as well as the enthalpy change. Okay, so we have also discussed this is a reversible reaction, which means it can either go from reactant to product or the product to the reactants. All right. Okay, now question 17 is tricky. Combustion of methane is exothermic. Now, whenever I see the word exothermic, immediately behind my head, what will I tell myself? It is going to be delta H. Delta H more than 0 or less than 0 exothermic. Can anybody tell me in the chat? Delta H less than 0, more than 0. Exothermic. Okay, Kaiji say less. Anybody have different answer? Anybody say more than zero? The rest of you, do you all know? Melissa, Hewon, Marilyn. Okay, exothermic. Heat exit the reaction. Okay, from high level, go down to low level. So my delta H, because it's pointing down, it will be negative. Negative means less than zero. Okay, so delta H will be less than zero. Fantastic. Okay, less than zero. So it's a negative value. Now, equation is given as below. So we have methane reacting with oxygen is a combustion reaction to form CO2 and H2O. Means it will give out heat also. So this reaction, it will give out heat. Okay, what can we deduce from this reaction? So option A tells us fewer bonds are broken than made. Fewer bonds are broken than made. Okay, B, less energy is involved in breaking bonds than it is involved in making bonds. C, more bonds are broken than made. D, more energy is involved in breaking bonds than it is involved in making bonds. Wow, this one's so confusing. You can see A, B, C, D, the answer are all directly contradicting each other one. Okay, so how do we do this question? If let's say, in this question, if you are smart, right, you just choose either option B or D because option A and C don't really seem that enticing. Okay, I will tell you why later. Now, option B and D, what it's going to tell you is they're talking about the energy involved. And why is it that I say option B and D are your smarter options? Is because this question is talking about energy changes, right? So when it's energy changes, there's a reason why the question tell you it's exothermic reaction. Now, sometimes, yes, I can say that, okay, it's just to distract you, but because we are talking about changes, okay, energy changes, so this is a big clue for us. Now, in this case, we are going to illustrate on an energy profile diagram. Okay, energy profile diagram. So this is an exothermic reaction, which means that it's going to look something like this. So I'm going to write out my P and R again. So over here, on the left is my reactants. On the right is my product. So reactant become product, right? So delta H is less than zero. Okay, and W change is less than zero. Now, with this understanding, we know, okay, that what? The overall energy release. Overall energy is released, right? That means I take less energy to break bond than release to make bond, okay, to form the bond. Okay, so answer for this question, will it be either B or D? Answer, do you think it's B or D? Anybody have any idea? Okay, good, Kaiji. The rest? Wow, Melissa, I say again, for the roller coaster to go up, this is to break bond. I need to break the bond first. Before I can go down, this is form bond. So you take a look, from here to here, okay, the energy required to break bond is this amount. This amount is the energy required to form the bond. Okay? Wow, I already say C. Okay. Everybody have different answer. One got A, one B, one C, one D. Okay, I need to explain already. Now, answer for this question is B. Yes, Melissa, correct. It's B. Okay, because, can you see over here? I'm going to tell you the reactant. Now, whenever we are talking about activation energy, from this point, can you see? From this point, I'm highlighting over here, this point over here, all the way up to this point over here. The energy increase, I'm going to highlight for you. This increase is energy is the energy absorbed to break bonds. This is the energy. Now, once the roller coaster have come to the top over here, it's going to prepare to go down, right? So it's going to prepare to go down. Now, this energy in green color over here, I'm going to explain to you. It is the energy that is released in forming bond or making the bond. Okay, so you can see over here, in this case, evidently there is more energy released than energy absorbed. So answer for this question will be less energy is absorbed than released. Okay, so answer B is correct. Now, I'm going to prove to you that option A and C are incorrect. Okay, so D we already settled. D is wrong because we already explained through this. Now, option A and C. Now, can you see over here, how do we count this? Fewer bonds are broken than made. More bonds are broken than made. Now, how do we count the bonds that are broken and made? Can you see over here first? We need to first draw the CH form. Can you see in the CH4, right? The CH4 look like this. Okay, this one you need some organic chemistry knowledge to know, right? So you can see that in one CH4, I have 4 of the CH bond. Now, next, I got oxygen. Oxygen, I got 2 of the O double bond O. So total, I got 6 bond already. Now, CO2, how does CO2 look like? CO2, remember, is 2. Okay, sorry, 2 of the carbon double bond with O. Okay, now water is what? Water. Now, water, you must be very careful. Water is like, look like that, right? Water look like that. And then the other molecule water look like that, right? So total actually is 4 OH bond. So can you see over here that in the product, we are forming a total of 6 bonds. Can you see that in the reactant, we are breaking a total of 6 bonds also? Okay, so Marilyn, we on the left-hand side, we have 6 bonds that are broken, 4 CH bond and 2 OO bond. And then for the right-hand side, we have 2 CO bond and 4 OH bond. So total number is still 6 bond, right? On the left and on the right-hand side, both are 6. So hence A and C are out because they are actually same number of bonds that are made and same number of bonds that are broken. Can Marilyn, can Okay? Yeah, okay. Now let's go down to question number 18. Okay, 2 more questions to go. Now, this one is on energy changes again. So temperature change when 4.0 grams of potassium chloride granules was dissolved in excess water. So there is a energy change of reaction of plus 720 joules. Okay, so in this question, what they're trying to tell us, this case of a potassium chloride dissolving in water, is it exothermic or endothermic? Can anybody tell me? Okay, yes, okay, absorb energy, right? So energy changes of the reaction is okay, so it's an endothermic, right? So you can see over here, energy change when 1 mole of potassium chloride dissolved in water, 4.0 grams. Now convert this to number of moles. Convert this to number of moles. Okay, number of moles. Okay, will be 4 over 39 plus 35.5. Okay, and you'll realize that if I take the 720 divided by this, I will get 13.4 positive. So this is correct. A is correct. Now, energy change will be greater when powdered potassium chloride is used. Answer is wrong. Okay, only speed of reaction. Energy does not get affected by the size of the reactant. Okay, only rate of reaction does. This one don't. Okay, energy level of the product is lower than the reactant. Answer is energy level of the product is lower than the reactant, which means it is an exothermic reaction. Answer is wrong as well. Product reactant. Answer is wrong. Sign of temperature change is positive. Answer is wrong because since it is plus 720, energy is absorbed, temperature should drop. Okay? Can question 18 okay? I think most of us are okay with question 18. Answer A. Now 19 is the long question. 19 is the one that is a very, very long question. Okay, so it's talking about a reaction between magnesium and dilute sulfuric acid releasing a gas. Can anybody tell me what gas is this? First, right off the bat, can you tell me what gas is this? Then very simple lah. Sec 3 also can. Okay, yes, fantastic. Hydrogen gas. Hydrogen gas is released. Okay, so in a series of experiments, 0.1 gram is reacted separately with different concentration. Keyword over here, different concentration of dilute sulfuric acid. In each experiment, the acids are in excess. Hence, what is the thing trying to tell you when they say that it's in excess? They are trying to say that all these are fully reacted. So all these kind of cue you need to know, okay? All these kind of textual cues you need to be able to find out. When they tell you it's in excess, one is in excess, what they are trying to drive at is that all of the magnesium are fully reacted. Okay, so let's look at this. Which statement is correct? Approximately reaction time when 1.5 mole of dilute sulfuric acid is used is 10 seconds. Okay, next one. The rate of reaction decreases with increasing concentration. The same volume of hydrogen gas is produced in each experiment. Now, in this, anybody have anything to say? Sorry, I just hear somebody want to say something. Oh, don't have. Okay. Okay. So in this question, first statement, the approximate reaction time for 1.5 is 10 seconds. Now, can you see over here that the concentration of sulfuric acid, right? In this case, you can see that it goes down, right? The reaction time go down all the way until 1. And you can see that it actually starts to plateau, right? Start to remain constant. So at 1.5, it's definitely going to be also 10 seconds. Now, why? Because as the concentration increase, it will increase to a point that the magnesium metal, okay, is already surrounded by so many of these sulfuric acid molecule, so it cannot react any more faster. Okay, so yes, this is right. Okay, so statement 1 is correct. So automatically C is out. Next, rate of reaction decreases with increasing concentration. This is definitely wrong. When concentration increase, rate should increase also. Okay. Now, third one, same volume of hydrogen gas is produced in each experiment. Yes, this is correct. Why? Because they tell you already the limiting reactant is the magnesium. So hence the outcome is only determined by the magnesium. It's not determined by sulfuric acid. So sulfuric acid, if I change the concentration, it only changes the rate. It doesn't change the amount of product produced. Okay, so answer is B. Okay, 1 and 3 is correct. Can? Okay, now let's move to the last question that we are going to go through for today. Question number 20. All right, it's talking about redox reaction. Okay, I have some question. Okay, somebody just text me. You cannot hear me. Can everyone hear me? Can hear me, right? Okay, can hear me, right? Okay, I think Margesh cannot hear me. Can you rejoin the Zoom? Okay, I think Margesh cannot hear me. Rejoin on your handphone. You try to rejoin on your handphone. Okay. Okay, back to question number 20. Now, bromine is extracted from seawater. They are telling you that there's this extraction process that looks like this. It is a redox process. First step, where I have bromine that is reacted with some nonsense that will give you this, that will give you HBr and sulfuric acid. Then in step number 2, this HBr over here is going to react with chlorine to give you bromine. Okay, bromine and Cl. Okay, so which role is correct? They are asking us in step number 1, which is the oxidizing agent, which is the reducing agent. Step number 2, which is the oxidizing, which is the reducing. Now, can anybody tell me what is an oxidizing agent? Define for me inside the chat. Anybody tell me? Yes, okay, good, Kaiji. Good. Yes. Oxidizing agent, Melissa. What is an oxidizing agent? What does it do? Why do I call it an agent? Lose hydrogen. Lose hydrogen is oxidation. It's not oxidizing agent. Yes, fantastic. Okay, so it reduces, it itself is reduced. It oxidizes something else. Okay, oxidizing agent means what? It causes something else to be oxidized. So if let's say A and B give you C and D. So what happens if A is the oxidizing agent? A itself is going to be reduced. B is going to be oxidized. right? Okay, so in this question, you can see over here, bromine, originally oxidation state is 0, next it become -1. All right, so you can tell that bromine is getting reduced by itself. So if bromine is getting reduced by itself, it is going to be the oxidizing agent. So hence, for A, it will be either A or D. Okay, now what is going to reduce? So you can see over here, sulfur dioxide. Now, can you see over here, sulfur have oxidation state of +4. This one, oxygen have an oxidation of -2, right? So in this case, after the reaction, sulfur have an oxidation state of what? This +2, this is +8, this is +6. So can you see sulfur is getting oxidized? So if sulfur is getting oxidized, it is going to be the reducing agent. So hence, option A is the answer. Okay, now step number 2, I also going to go through review, right? So but just that from step number 1, I can already tell which one is the answer. Okay, reducing agent is the SO2, right? Because S is S is oxidized. S is oxidized from +4 to +6. Okay, now step number 2, HBr, Cl2, Br2, and HCl. So can you see over here, chlorine originally is 0, now it becomes -1. Hence, when it reduces itself, it is called the oxidizing agent. HBr. Now, HBr originally, hydrogen is +1, bromine is -1. Now it becomes 0. Hydrogen remains as +1. So you can see bromine is getting oxidized, and hence is the reducing agent. Okay, so answer A for question 20. Any question? I hope you are able to understand this. Okay, so this is on redox reactions. Okay, teaching you about oxidizing and reducing agents.